Okay, let's get started. A little early today, but that's fine. So, um, today's a little bit of a hodgepodge day. So it's not going to cover a big specific thing, but we're going to cover two things, and they are references and operators. So let's start with references. And what's a reference? A reference is uh, not the thing itself, but the location of the thing. So let's say we had a struct like bank balance. So type bank balance struct. And the bank balance has an amount. And we'll just make it a float 64. Okay. Uh, and we want a deposit method on bank balance. So we want and we want an amount to be deposited. So what should happen when we deposit the money? Well, the amount in the bank, we add the amount to the amount in the bank balance, right? Okay. All right. So there's a clue that something's not going to be right because we've got a little yellow squiggly telling us it's an ineffective assignment. But let's go through the exercise. So let's go ahead and create a new bank balance with an amount. And notice we don't really actually have to include that, but we can say $100. Okay. Now we're going to call deposit, and we're going to deposit $10. So how much should the bank balance have? Well, in theory, $110, right? So let's okay. So let's go ahead and run this. Like I said, the little yellow squigglies are a giveaway, right? Um, well, the balance is still 100. Okay, so why doesn't that work? Because effectively, when we declare a method on a type like a struct, this is essentially a parameter. So essentially we're passing, it would almost be as if we had written something like deposit, except the difference is the method becomes more part of bank balance's type than this does. So, okay, let's go back. Okay. Now, if we pass a value of something and we modify that value, we get a new copy. So when we pass $10 here, let's say I have deposit amount equals 10. Oh, that should be colon equals. Whoops. So let's say I'm doing that. And down here, I charge a fee on the amount. So the amount deposited is minus my fee of 10 cents. Okay. And let's go ahead. So we can see that neither value was modified, right? So when we subtracted 10 cents off the amount, it didn't change this value here, right? Even though we passed it in here, we did the subtraction, it did not change it. So why is that? Because when we invoke a function and we pass a parameter that is a value, we get a copy of it. So if we were to look into memory, we would see, and this when this function is executing, if we were to look into memory, we'd see there is some memory set aside for this. Then we get another block of memory set aside for this. And it gets a copy of the contents of this. All right? So this is a copy of this. And so any changes we make to these copies, this is a copy of this. So when we call bb.deposit, we are passing a copy of what we have here as bank balance. So this is a copy, this is another copy. We modify the copies, well, that doesn't change the original, right? So how do we fix that problem? Well, instead of passing the value, we want to pass the location of the value, so we refer to the same piece of memory. So rather than sending in a copy of the deposit amount, we want to send in the location of where the deposit amount is stored, and then we can modify it. So the way we do this is by passing a reference. So let's go ahead and set up here, and we'll say okay. So what's going on here? So I just added a bunch of weird little characters and what's going on here. So when we want to pass the location of deposit amount, not the deposit, not a copy of the deposit amount, but where the actual deposit amount is stored so we can modify it, we use the ampersand operator to take a reference to that variable. Excuse me. So what we're passing here is not the deposit amount, we're passing in the location in memory of the deposit amount. That means our function needs to accept a reference to the float 64, right? So we're no longer passing the float 64. So if we did this, remove that, and we tried to pass a value to where we expect a reference, we see we get a red squiggle. That's not allowed. We need to pass a reference. So we're going to get the reference by using the ampersand. And here, if we tried to remove that, we get an error saying down here saying that we can't pass a reference to where we expect a value. Okay, so we're passing the location of amount. So now we need to say, hey, I'm modifying or I'm changing or I'm referring to not the location, this is the location. We could call this amount ref. So we're no longer talking amount ref. We want to modify the value located at amount ref. Well, we do that by what's called dereferencing, and that's using the star. So this created a reference. The ampersand creates a reference. The star dereferences, meaning it exposes the underlying value to us. So we need to dereference this and this. So when we dereference this one, amount ref over here, what we're saying is for this mathematical operation, don't use the location, use the value at the location. And we will subtract 0.1 off that value. Now, this is saying modify when we calculate this number. So this is whatever is minus 0.1. When we calculate that number, we want to store it back into that location. So that's what this is saying. By dereferencing by dereferencing it and having it something that we assign into, we're saying put the value that we calculate here into that memory location. And oops. Okay. Now, when we want to use this in other operations, we don't want to say the reference. So sometimes, yes, we do want to say the reference, but if we are passing a reference to a number and we want to use that number in calculations, for example, we don't want the reference to the number. We want the value at that reference. So here we're going to add the value at that reference into amount. So if we run this now, okay, we see that the balance wasn't modified, but the deposit was. So in fact, we did modify this. Now, when we created a deposit of $10, we passed not the value $10, but the location of where that value is stored, the variable deposit amount. Our function accepted a reference to that amount. We use the value at that reference in our calculations. And so when we return from this method, we have modified this value. Okay. So as you can probably guess, remember what I said, that creating a method on bank balance like this is essentially the same as passing bank balance as a parameter. The same rule applies. If you want to modify the structure on which you have a method, you need to pass a reference. So in this case, we're going to pass a reference to bank balance. And now we see our little yellow squiggly is gone. Why is our little yellow squiggly gone? Because now that we're passing a reference to bank balance, when we have this operation, we are going to modify this amount. So therefore, this assignment has a value. I mean, it has a purpose. I shouldn't say value. This assignment now has a purpose. Before, when we weren't passing a reference, this assignment had no purpose. Why didn't it have any purpose? Because as soon as this function returned, the copy of bank balance, which is thrown away, leaves the original bank balance unmodified. So we assigned a value assigned the field in bank balance a new value, but because we weren't passing a reference, it didn't change bank balance. Okay, so now we're going to go ahead and pass a reference to bank balance. Now, if you'll notice, we only have to do it once here. We don't have to do anything here. We don't have to say and BB, right? We don't have to do something like this, although we can. That's perfectly legitimate. So Go is doing the work. So we had the whole ugly mess exposed here where we have to dereference it to be able to use the value. Go, when we have this kind of method referencing, its associated type, Go does a lot of the work for us, so we don't have to worry about it. So we can just do the operation. And now, let me go ahead and save this. Now, if we do go run dot, we see that the balance was increased by $109.90. Or sorry, the balance was increased by $9.90. And that is because under the covers, Go, instead of passing a copy of bank balance, Go passed a reference to bank balance into the deposit method. And we were able to modify bank balance and return. And when the method returned, we had a modified bank balance. Okay. This doesn't just work on structs. So let's do func. Let's say this is, let's create a type. age, and it's an int. Okay, and we're going to have a method, and it's going to be called, we're going to take an age, and we're going to call the method birthday, and that increases age by 1. So, or yeah, it increases age by 1. So a plus equals 1. Okay. So as you can guess, so what's going to happen here? Well, when we run this, we see age isn't modified. That's because, again, this is almost the same as that, okay? So we're passing in a copy of age, we're modifying that copy, and then the original age, where we got the copy from, is never modified, right? So what we need to do is we need to pass a reference to age. Now again, when we had to do it for this amount, we had to do all this work to dereference it, etc., etc. If we do this, and we just say we want to modify the value of age by 1. If we run it, we see now age is modified. Okay, so that's references. And I'm going to actually touch on it again the next time we get together, because it does take a while for this to sink in if you're new to programming. Yes, it's not like it's not it's not how a lot of people think naturally about this stuff. Um, but it will sink in, and references will become second nature. So let's go ahead and get rid of this for now, and we're going to talk about operators. So this is kind of related in the sense that we were using the operators to get a reference and dereference, excuse me, for the neighbor taking down a tree. So we did the reference and dereference. We use the operators to get the address of something or use the value at that address. So we're going to talk about basic operators. So so for integers, we've got the usual suspects, right? We've got addition, subtraction, multiplication, division, right? Okay. So let's go ahead and print those. All right, so we get our answers, right? The one change is that for computery stuff, let's say we had, so in this case we had an even divisor, right? 4 and 2. Let's say we had what is the value of E? Well, most of you would say, well, it's 2.5, right? 5 divided by 2 is 2.5. So let's print it out and see what we get. Wow, I'm really sorry about that. I thought they were going to be done yesterday. Let's save it. All right, so we see, interestingly enough, let me label these A, B, C, D, E. Okay, so we see E is 2. So 5 divided by 2 is 2. Well, that might not have gotten you the correct answer in grammar school, but that is what the computer does. So integers, remember, are whole numbers and only whole numbers. So there's no 2.5 whole number, right? So when the computer divides by 2, it effectively kind of rounds to 0. What if we have -5? Well, again, -2. What's actually happening underneath the covers has to do with the way that integers are represented, but I won't cover that now. I just want you to be aware of this. Now, so how do we get the remainder of that division? So let's call ER 5% 2. Now we've seen percent before when we did the die rolling, right? So we've got E, let's put in ER here. For E remainder, if we go run this, so we see that E, 5 divided by 2 is 2 with a remainder of 1. Okay, so that is the normal staple of bit of addition mathematical operators. Then we have comparison operators. So if A greater than 2, A is greater. We have less than. And we have combinations with equals. So if D greater than or equal to 2, okay, so if we run this, we forgot to put in new lines, but we see the output from our prints, right? All right, and these should have been print ln because I wasn't really formatting a print line, right? There we go. All right. So that is integers. And so that should be, except for this, which is new to people who are not been programming, and we did use it before in a previous episode. These should be the usual suspects. So let's now look at the next numeric type, which are floating point values. So A is equal to 1.0 plus 1.0. B is equal to 2.0 minus 1.0. C is equal to 3.0 times 4.0. D is equal to 4.0 divided by 2.0. And E is 5.0 divided by 2.0. Now we don't really do modulo division in with floating points because the remainder is inherent in the fact that we've got a floating point number, so we can represent 2.5, right? So we do format printf A, B, C, D, and E. Okay, if we go run this, all right, we see our values, and again, we see that when we do a division here, excuse me, we get 2.5 because we're using floating point values. And of course, the usual comparison operators apply, like so again, we have greater than, less than, and then we can combine them with equals. So we have we go ahead and run this. We see our comparison operators. Okay, that covers our numeric values. So now let's take a look at strings. So strings, it's really only one operator that we have. So if we have message, and body, so we can see that our really one operator here is the addition operator, which combines two strings. So there isn't a ton to go on here. And the last thing that has a operator are channels. So I'm not really going to do much of a channel example here. Well, let me do a short one. And so WG, so this was one thought out. Um, Okay, so what is this, really quickly, what is this example doing? This is using Go routines to start receiver to run as a separate Go routine from our main Go routine. So Go routines I'll cover later on. But essentially, we're creating a channel, and there are a couple of operators on channel. There's a receive operator, where you've got the channel on the right side, and you've got the send operator where you have the channel on the left side, and it's this arrow operator. So if I go ahead and run this, it's not very exciting. Oop, it deadlocked. Well, that's what I get for trying to do this off the top of my head. So basically what I was trying to do is start the receiver in a Go routine. Have it wait until I send it an integer. So until it's actually able to receive something off its channel, it's just going to sit there and wait. And when it does receive it, it's done. So the wait group starts with, I'm going to wait on one thing, and when that one thing calls done, the wait group's finished. But anyway, long story short, there are two operators on channels, and this closes out the two operators. So those are the operators, and I'm just doing this for completeness. We'll come back to wait groups and Go routines and channels later, much later. But yes, so this completes this just completes kind of the coverage of operators. Okay, so that's references and operators. References, again, you need references to uh, again, we have, if we just have that, if we just have we just have that, right? If we just have this, we never actually change the value in bank account, right? We have to pass a reference to the bank account where we're passing the location of where the bank account data is stored, not a copy of the bank account data which is what we're passing here. And we do that by just giving it a reference, right? We covered references. We covered the basic operators like addition and comparison operators. And so that should basically set us up to do something useful. All right, well, that's it for today. I know this was more like a laundry list of stuff, but I promise the next thing we'll do something that's more useful than these kind of really short example toy programs.